Hello, everyone, and welcome to today's webinar. We will start in just a few moments from now. Thank you. Hello, everyone, and welcome to today's webinar, which is Building Machine ID for Milter Machines Part 4. This is another continuation in our series on this. And again, this will be given by Marina Vilkina. And we've actually also sent out an email with the links to recordings from the 3 previous webinars that we've done on this. This is a very important subject for everyone, so please get as familiar as you can with this. This is why we're having this series of webinars. Now, before we actually start the webinar, I'd like to also remind everybody is that we have our SolidCAM World 2020 coming up in May in Istanbul, Turkey. And we've had many people already started to sign up. And I'd like to see everyone over here actually sign up for the for SolidCAM World as well. So on our website, in the reseller areas, we have the invitations over there if you don't have it in your email. And anyone that is a reseller or staff can sign up. So we like to see everyone as soon as you can. Okay, Marina, I will make you the presenter, and you can start the webinar. Okay, go ahead.
Okay, thank you, Sydney. I would like to check again if you can see my screen with the
Yes, I
presentation on it.
can.
Okay,
No
very
problem.
good.
Go ahead.
Very good. Thank you. Hello again and welcome to the last webinar in this series. And today I'm going to talk about MCO operations, MCO cycles, and a little bit about device options. Again, I will use Machine ID and part project from the previous session to show you the process of building MCO cycles and some features of this item. As you know, each device which you are adding to the Machine ID has the option sections inside. This is very important section, and it allows you to add more features and more functions to your post processor. And because this, what you adding inside the Machine ID can appear inside the trace, and you can output these options in the final code. So you should arrange this list of options according the options of the machine. You can add some fluid options here, which is called coolant, synchronization, and so on and so on. Of course, for the transfer operation, the main device for me will be main spindle. And I would like to explain a little bit the process, because maybe some of you may be not familiar with it. So when you change the status of the option listed inside the device of the Machine ID from known to any other, they are different, and the types of the variables connected with these options will be different. So after you change the status of the option, you will be able to see it inside MCO operation when you will add to it the relative device inside the process section of the MCO, which we're gonna do today. And after you add it to the MCO option, you will be able to see the relative procedure inside the trace code and the relative variables. So it will be system variables, or you can add your own variables. This is very important process, especially for Swiss type machines. So for today's actions, I'm gonna do cutoff and transfer, quite standard operation, but maybe it will be interesting because it will be on a Swiss type machine, and because I will show it in the context of of the MCO cycles for Swiss type machines. I will need to change some things for the section of main spindle. Of course, I will need spindle synchronization mode to be on, from known to on off, and of course I will need the axis synchronization and rotation option. I will explain a little bit shortly what's the difference between spindle synchronization and axis synchronization. Spindle synchronization means that I can, after this command on the machine, I can have the same speed of rotation with main spindle and sub spindle. By the way, on Swiss type machine and on the most two-channel machines, we can have the both functions. For example, if I will give this command on the first channel, the second spindle will follow the main spindle, and I will have the same process if I will give this command on the second channel. The first channel, the first spindle, main spindle, will follow the sub spindle. So it is very important where you turn on this function. If you will turn it on under the main spindle, you will have your sub spindle follows the main, and when you will turn on it on the back spindle, if you will turn on it on the back spindle, you will have the process of following the main spindle after the back spindle. So this is the synchronization of speed, and maybe the phase synchronization, like a C-angle synchronization. And the second very important option, which is used not only for cutoff, it is also used for the special operations when you have the synchronized Z-axis, is the axis synchronization. For the spindles, as you know, they have both of the spindles has their own Z-axis. We have Z1 for the main spindle and Z2 for the back spindle. That is why when I'm asking to turn on my axis synchronization here, I will have the Z synchronization. But for other function, and if your machine can do this, you can have the synchronization of other axes, for example, C axis too. Of course, so I turn on this operations, turn on these options, and also I will turn on my rotation options, because it is not enough to turn on the spindle synchronization. I should set the speed of synchronization and the direction of rotation. So that's all I will need, all changes that I will need in this section of the VMID. So now I would like to, before I'm going to MCO operations, I would like to consider the process of transfer on this particular machine. It is very important to have the example of codes and to understand what is inside of the code, the meaning of all these commands, and the meaning of the processes related with these commands, what's really going on the machine. It is extremely important to have a good output from the software. So I divided everything which I gonna have during the transfer on several blocks. The first two blocks are the main important, maybe, because most of the changes will be inside these blocks. I will make a quick review of the code so you will understand what I'm gonna add to the MCO operations. So here I have the standard code for this machine. First of all, I should call my cutoff tool. I will call the tool number, and also I will call the tool offset. Then I should put this tool to some X position before cutoff. Then I will turn on the rotation of the main spindle and of course, the direction of the rotation. This is important because I may have the other type of direction, because my tool will have the other type of position. Maybe it should be counterclockwise. And after that, I should pull out the part out of the collet of main spindle. So this is the position of the cutoff. This position will depend on the length of the part and also the extra allowance for the back face. Also, the same process I can use not only for the cutoff. I can use it, for example, to represent the synchronous turning with 2 z-axis and the OD turning tool on the first channel. And after that, these 3 lines is the commands to synchronize spindle speed and spindle's phase. So after this command, my second spindle will start to rotate with, for this particular example, 2000 RPM with M3 direction. After that, I'm going to the second channel, and here I have 2 commands to open the chuck, to position the subspindle to Z2 home position. And this is very important command too, and it is frequently, you can find it very often for 2-channel machines. What this command means: this is a nut cutting tool. This is my subspindle. So I would like to have all other coordinates of to position the subspindle nearby the stock and to clamp the stock after. I would like to have these coordinates according the part coordinate system, according to Mach 1 position. So Z14 means 14 millimeters before the face of the part, and Z-6 means 6 millimeter after the part 0. To have these values as the coordinates according the system of the part, I should add to the CNC, I should add the offset of the subspindle. So on the machine, operator should manually put the subspindle nearby the part and measure the offset. And then after the offset of the subspindle will be inside the CNC, and it will be under T4040 number, I will be able to present all this process according the Mach 1, according the part coordinate system. So this is important, but to use this, it must be added on the machine. By the way, for these machines, T40, and for the most machines, it is like reserved values. For example, for the Mitsubishi and for the QuickTech, T40 is always used only for the subspindle. There is no T40 cutting tool inside the machine. So this is important. That's how I'm calling the offset of my subspindle. And after I call this with this way, I can move it according the coordinate system of the part. So X0 is the coordinate of my part. That means my subspindle will move by X2 to be right opposite the main spindle, and after that I will move it by Z. I will move it 40 millimeters before the stock face with G0 speed, and after that I will move it very carefully with the certain feet to the part, and this will be the clamp position. And after I will reach the clamp position, the subspindle should be closed. So this is the command to close the subspindle. After that, I'm going back to the first channel, and this is the command to turn on a Z-axis synchronization. So Z2 follows after Z1 axis. Then I will perform the cutoff operation. Then I will turn off the Z-axis synchronization. Also, I can add here the turn off the spindle synchronization, stop spindles, and whatever I like. After that, I'm going back to the second channel, and my subspindle should move with the part out of the cutting zone and to reach its new destination. Maybe I would like to move it to one of the turrets with the tools for machining on the second channel. So that's what I'm gonna add to the project, and that's how I would like to build this process inside the SolidCAM. So here I have just a few operations. I already made a face operation, and I have my CAD cutoff operation, to not spend time and to focus only on MCO operation. Very simple two operations. So here I will just add machine control operation. By the way, we have like a recommended list for the names inside the MCO cycles. This is the list to naming the cycle parameters. So it is recommended to add VMID and the first character of the type of the variable. And also I have a recommended list for the names of the cycles that should be added to the MCO operation. So it's like a standard where we would like it will be standard. And here I will use some names. So the first block will be about the preposition of Z1 and X1. So I will call it like Z1 preposition for cutoff. The next very important thing is about the submachine, which will be used inside the MCO operation. The submachine will influence on a channel where I will have my MCO operation. Why it happens? Because I have a list of the submachines inside the channels area of the VMID. If I'm going to the first channel, I can see that I have submachines here, gang main spindle and gang back spindle. So whatever MCO I will add with these submachines, I will have it in my first channel. If I would like to have it in second channel, and I will have some operations in second channel, MCO operations, I should add it as T2124 back spindle, and I add T40 additional submachine for this process. So I'm going back to machine control operation, and I will create Z1 preposition for cutoff in the first channel. After that, I can add my actions. It will be very simple. First of all, I would like to add the tool call. For example, you can influence on the order. It depends on you and your customer what order he would like to see here. So I will use the tool change action, and here I would like to select the turning tool, and it will be my cutoff tool. After that, I would like to go to the main spindle and to turn on some rotation before I will synchronize my axis. So I'm going to rotation, and I will have it, for example, like 500 RPM. And I would like to say that this value will be used only for the synchronization, and it is recommended. Some suppliers has such recommendations to not put here the exact value which will be used during the operation. In our case, it's a cutoff operation. So it's like to start movement, because you should notice that this value after the synchronization will be used for the second spindle, while it will clamps on the part. So maybe it will be better to not have a high value here, because we will call rotation again inside the cutoff operation, and or we will apply a new values for the cutoff tool. So this is like it may be like some recommended value from the supplier, or if you would like, you can use the same value as you gonna use inside the operation. So I will have my rotation, and then I would like to move my tool and move my part. So for the movement, I'm going to use submachine action, submachine device, and here just a second, I would like to save and calculate before I'm going to use movement. And here, after that, I can use it, and I prefer to use to use this option with machine preview window. And here I have my stock. I will show the machine again. So here I have my cutoff tool, and I have my stock. So I will use the front view, and I'm gonna, first of all, according to the code, I would like to move my tool by x-axis. So 5, it's a radial figure. So in fact, I will have 10 millimeter diameter here. So I will use it like a 5. As you can see, my tool moved on a x5 or x10 according the machine coordinates, machine output. And after that, I will add some value to the position. And I know that my part has a length of 32 millimeters, and I would like to add some extra material, extra allowance. So I will make it like -33, and I can see it here. It's extremely comfortable, extremely good function. So you can see everything which going on here, and also you can add a check. So you can move your tools here to check what's going on, if it is okay, and this distance will be okay for you. So it's okay for me. I will save and calculate it. And now I will add the second operation. It will be the back spindle catch position operation. I will add a new machine control operation, and now here I will change my submachine to have this operation on a second channel. I will use T2124 back spindle submachine, and here I will have only two devices. It will be back spindle. I should prepare it before I will move it. I should unclamp it. So I will use the clamp option and will open it. It is allowed to open the subspindle during the rotation. In our case, we have a special command for it. It's M802. If I will use this command, I will be able to unclamp my subspindle during the rotation. So it is normal for the machine. Okay, I have my clamping, and now I would like to move it to its destination. I forgot to add a name to the operation. I will call it base catch position. So here I have movement again, and I will open my machine preview, and I would like to move it in the coordinate system of the part. So the first movement will be the movement of the subspindle right opposite the main spindle. So I would like to have my X as a 0. After that, I would like to move it by Z. I will delete it. Save. Try again. Okay. And here I should move it to the face of the part on a safe position, and then I should clamp it on a certain feet. So here I will use, for example, 10 millimeters before my face, and 10 millimeters after the part, 0 after the face. And I would like to use it on a certain feet. So I will add some feet here, feet value. So after that, I should clamp my subspindle. So I will add one more back spindle device here, and in clamp process, I will add close. Okay, now I should turn on synchronization mode. So I will add again machine control operation, going back to the first channel. And here I will add it for the main spindle as axis synchronization. So my Z2 will follow Z1. Z1 is master, Z2 is slave axis. That's all I will need. Oh, just forget again to add the name for the operation. Here I will have my name, and I will add one more operation after cutoff. So after cutoff, I will turn off my synchronization, Z synchronization mode, and also I can turn on synchronization of spindle speed. So I will turn off axis synchronization, turn off spindle synchronization, and I can turn off rotation at all, just off. That's all. That's all for the first channel, but to the second channel, I should add a very important feature. First of all, I will call it back spindle home with part. I will choose the submachine for the second channel. I will choose my back spindle, and the very important thing which I told you, it's about clamp process. I should say that now my stock is completely on the second channel. So I'm choosing close on stock operation. That means that I have my first channel as empty. There is no more part inside the first channel. It's completely on the second channel, and I can use operations on the second channel. So I will close on stock, and after that I will use part movement option. And here I will use it. Oh no, wait a second. Okay, I will need to reload it. I'm sorry. It happens, especially during online sessions. I will load it again. Okay, so I should repeat some process. Okay, try again to create a separation. So back spindle home with part, adding back spindle and adding my close on stock. I will save and calculate. And after that, I believe I will be able to, oh no, I forget to change the channel. Now it should work. So once again, part move, and I'm going to move it to home reference position by Z axis and X home reference position. Hope my machine preview will be okay. So I will have my top view. So I have my part here. It is on the back spindle, and it moved to Z2 home position, and after that it will move to X home position. Because after this I would like to make the face operation here and some milling with these tools. Okay, hope it's okay. I will unsuppress some of my operations for the back spindle. Calculate. And I will check my process in machine simulation. And after that, I will add MCO operations, MCO cycles, sorry. I have just several operations here, so it will not take time to check the simulation. It is very important to check if simulation is okay and process is okay. So here I have my stock. I will have my face operation. So the cutoff tool is positioned and my stock is out of the collet. After that, my sub spindle moves to the stock 10 millimeters before the face, 10 millimeters after the face, cutoff, and part is in its sub spindle home position. It looks good. So now we should on the real machine, the most of this process are copied from the previous operations with the operator, and some figures are changed manually, some parameters, I would call it like that. So for example, the position of the sub spindle, the speed of the stock during for the synchronization process. I prepared a list of the parameters which I'm gonna add to my MCO operation. So what I'm gonna make like a variable, because the most of the code will be the same for this machine and for this process. So what I'm gonna add as a parameter, I'm gonna add the number of the cutoff tool, the direction of the rotation before spindle synchronization, the speed of the rotation, if it may be vary by customer, the position of the stock for the Z1, and the position for the tool. For the second channel, for the second operation for positioning back spindle, I would like to have influence on the preposition of the back spindle, clamping position, and the feed of the position. Other three operations will not have any parameters because it is standard and constant. I will never use values here. So I will add some variables here, like parameters. Here I will have the first parameter I will have here is the number of my tool. So I will just click add a parameter and we'll add it like a tool number with the recommendations of the support team. So it is integer, VMID, tool number. This second parameter will be about rotation, and here I will have two parameters. The direction of rotation may vary depending on the tool position, and of course the speed of rotation may vary too, but in some cases customer prefer to leave the constant value here, and you can leave it constant because, as I said, it's not the speed on which we will perform the cutoff or other synchronized operations. And of course, I would like to have influence on these two parameters because they will vary depending on the part geometry. I will add the one more parameter here. It will be like move X. And the last parameter here is move Z. That's all. And I will add some parameters for the back spindle operation. It's not a long list. I will leave my clamp because I will always have unclamp operation here, but I will change these two values because I will always need this value during the transfer. So it will be constant. I will not gonna influence on it, but I would like to influence on the Z position. So this is like a preposition value. So it's Z2 preposition before the clumping. And I will add it like Z2 preposition. And also I will have my catch position. And VMID catch position to have a possibility to see it inside the trace and to use it. What else? So close spindle, I don't need parameters, any parameters here. Okay, and I will not need any parameters inside these other MCO cycles. So now I can create my cycles. To create a cycle, I have a special button here, which is called cycle, and save MCO operation as a cycle. And I would like to pay attention on a very important thing here. You have a full trace option here. And by default, it is not activated. Today, I would like to show you the difference between the full trace and without trace output for the MCO cycles. So I will create the two cycles from each operation, which I added with the parameters. So we can see the difference between these modes. So the first one will be by default without full trace. It's Z preposition for cutoff. It is okay. And I will create one more cycle from this MCO operation, but with a trace function. So at the end, I will add trace. And I will add this tip, full trace. Okay. And after that, I will do the same with my back spindle without trace by default and with trace. And this tip. Okay. So now I'm going back to my machine ID, and in the controller definition section, I can see my new cycles here. So I created 4 cycles and I can see them all. I can manage with these cycles. So I left all information about the cycle inside VMID. So when I will close this project and I will go to another part, whatever, with any geometry, I will have this sequence and I will have these parameters here. This is very important, and this is the feature that you can use to make your posts and process better. So here I have the list of the parameters I created. I can change its names and I can change its default values, especially for the numerical and integer variables. Also, what we can do here, we can edit this cycle. And during editing, if it is not your VMID or if you forgot what is inside, you can go there and check what is inside. You can also change something. You can add new actions, or you can change everything which is inside of these operations. You can get rid of parameter, for example, or assign a new parameter here. So this is the feature to change it, and so it is not the constant, and you don't need to going back to the original project and to change something here to save again. You just need to go inside the MCO, inside the machine ID. So this is a very important feature. And also you can change the names of the MCO cycles here. So now let's check what's the difference between these two cycles. So here I still don't have cycle. I have my machine control normal operation, but in technology page I have my cycles, and I will choose the first one, which is without trace. And the main difference for us that we don't see the sequence of the actions of the processes here. I can see only a list of my parameters, and if I will click on the parameter and choose, for example, this is the parameter of the coordinate. So here I can see what is going on. Where is my X? Where is my Z position? And also I can choose a new tool, for example, here, whatever I like. So I will calculate it, and I will check the output of the code. So I remind you that this is cycle without full trace output. Because this is two-channel machine, I have two programs, second channel and the first channel. And here I'm trying to find the trace for my operation. So I will have only several headers here. I will have the process of start mash control, MCO cycle, and mash control. That's all. And inside MCO cycle, it's just a few lines of the trace. So I will see the MCO cycle name, so I can manage with the output based on this name. Also, I can see the names of my variables and the values of the variables here. I would like to pay your attention on the tool number volume. As you can see, please remember this figure. This is 1. And if I'm going back to my tool table, I can see that in fact the real position on the machine is not 1. 1 is just a number in the list. So it may not depend on the position of the tool inside the machine at all. My real number and how I'm going to call this tool is 31. So that means that for this particular operation, I will need a full trace output to have a possibility to get all information about this tool as I can. So I'm gonna use my cycle with full trace. And let's check what output we will have after this. So I have my first channel here. And here, after start mash control, I have a long list of the procedures, because each my motion action process inside MCO, even it is a cycle, but it is a full trace cycle, I will see it completely. And I will have my turn change tool here, and I can take all information from this procedure to output it inside the code. So this is the main difference. But for example, for the for my second MCO cycle, I don't have such conflicts. I will have completely only 2 parameters. All other parameters I will not need. So in transfer, I can see that the only parameters that has a meaning for me is the positions of my subspindle and maybe the feed of the movement. I forgot to add these parameters, but you can do this completely as I did for the coordinates before. So I will need only 3 parameters here. All other code may be outputted as a hard code. So you just add this code, add these lines, and put just 3 values here as the variables. And this will be shorter, and you will not need to get the pieces of the code from different procedures and to get it together. So let's check. I'm using the output without full trace. And here I will check the second channel for this particular process. and I have my MCO cycle, and I have just 2 parameters here because I forgot to add the feed value, but I have it here. I have it names, and I will just insert these values to the hard code, which I can add to a GPP file. When you're creating the MCO cycles, you should understand when you will need the output with full trace and will not. And it is, of course, it will be shorter and easier to output MCO cycle without trace. But in some cases, you will need the extra data. You will need the more variables for this process. And of course, this is the last step inside the creating machine ID. MCO cycles and the processes you can add here. Also, you can divide it on the groups. For example, these cycles for the transfer. You can have other cycles for example, to position your subspindle to some turrets if it is needed for the machine, because the structure of the Swiss type machines may differ and may be very complex, and you may need a long list of MCO cycles to not spend time adding all the procedures to each project. So it's all for today. Thank you for joining the webinar. Thank you for being here, for listening all this series. I hope it helped you, and I hope you will use this knowledge in future for your future VMID files for your project, and I hope it was helpful. So thank you very much for your attention, and I hope you will spend your holidays very good, and thank you and good luck.
Okay, Marina, thank you very, very much. And this was an extremely well done series of on this webinar. Again, this has been recorded as a previous one and will be available for everyone to view later on. So take care, everyone, and have a great weekend. Bye-bye.